think of Cartesi Rollups as this modular execution environment, which you can, deploy on top of Optimism as a layer 3, on top of Ethereum as a layer 2, and the world is kind of yours. We're very we want to basically scale Ethereum, so we would recommend using Ethereum and Optimism, but the choice is yours. You can deploy Cartesi on top of other EVM chains essentially. And again, coming back to what I just mentioned before, in terms of opening up the design space for execution environment, what we can do essentially is tackle this second problem, which is content scalability, and actually bring much more content to Ethereum. What we want to do is make Ethereum more programmable, right? And the way we do that is basically although we run on top of EVM chains, we have a custom virtual machine, and it's RISC-V based. So RISC-V is this platform processor. It's this open standard instruction set architecture similar to the one you have in your phones, and now also M1 chips, so laptops as well, tablets, etc. And having this combination of a RISC-V VM and this idea of application-specific rollups and the compute that comes with it allows us to put a full Linux operating system on top of it. Right? So think about that. Not only do you get this cool penguin, not only do you get Linux, you can not only can you use Linux, but what does that actually mean? It means that you can actually tap into all the content that runs on top of Linux. So that means you can use languages such as C++, Rust, Python, etc. to build your DApp, but you can also tap into complex libraries. You can tap into the ecosystems of C++, the Rust ecosystem, the Python ecosystem. You can even use a database for your DApps to build smart contracts, etc. So that's truly revolutionary, and it's the power that is enabled by having this compute enabled by application-specific rollups. So yeah, just to conclude this section, Cartesi Rollups is this combination of application-specific rollups and an expressive execution environment for Ethereum. So you can use the tooling, languages, libraries that you love to build your DApp. And so yeah, I just want to start with this so that we can kind of get that mindset in place. We don't have these issues of block space constraints, so we don't need to optimize for minimizing interactions with the blockchain. We can build way more complex stuff, and we can tap into a bunch of content that was previously not accessible. So let's kind of get into some of the showcases, some of these ideas that were built on early on, these proof of concepts, and some of these applications that are in alpha stage that are kind of being developed continuously at the moment. And there's different verticals that we want to tackle that were tackled at the moment. Remember, Cartesi is this general computation environment. So you don't need to restrict yourself to one of these verticals, but these are some of the areas where we've seen some interest already. But there's many more that you could explore as well. So starting with on-chain games and going all the way to DeFi as the last example. And I have Gabrielle and Carla here today, and we will go over some of these examples, some of the applications, and feel free to drop your comments in the chat if you have some thoughts. Gabrielle and Carla will be able to read the chat as well as we move forward, and maybe some questions can already be answered while we move forward. But yeah, let's get started with this. We'll get started with on-chain games, which are super cool. They're kind of redefines what games actually are, because instead of having we're familiar with blockchain games, I guess you could call them, where we have NFTs that live on chain, but they're more like Web 2.5 games. I mean, the NFTs don't really, they're cool, they live on chain, but they don't really, they're not fully leveraging the power of the blockchain of on chain, right? On-chain games want to move way more of the game on-chain. It doesn't have to be the full game, but at least the game logic is moved on-chain. And that really creates completely new dynamics and kind of redefines the genre, the gaming genre as well. So we have a couple games here, and And Carlo, maybe you could start talking a bit about Ultra Chess, which is a super cool game that was developed or that is being developed at Blockchain at the moment. One of our community members. Yeah, Carlo, what are your main takeaways from Ultra Chess here?
Cool. So, as you said, the Ultra Chess is being developed by a community member, which is super cool. And it's a really cool idea. So basically, the idea is that chess today is a game which people cheat. They just play against computer, reproduce the opponent's moves, and then throw back at the opponent whatever the computer did, right? So the idea in this game is, okay, let's actually not try to fight against it. Let's make it part of a game. So what this game does is you program a bot and you upload it to Ultra Chess, and then it fights all the battles for you. And well, this game is developed in Python, which is a very high level language, unlike Solidity. So it eases the burden of programming the whole logic. It also uses Linux capabilities of sandboxing for executing these bots that any player can upload, develop on the language of their choosing. And it actually uses a well-known protocol for playing chess so that you can plug in existing engines. So Swordfish and others can be used and can be tuned if you want to be your champion there. And you can always make usage of machine learning techniques that you want on your bot, or use any library that you'd like to do some optimization or any other calculations that might benefit your bot decision making. So it's a really interesting game, and it takes full advantage of having an OS as an execution environment. Yeah, you want to talk a bit about Cartesi battleships now?
Yeah, we can go over Cartesi battleships.
So Cartesian battleships, it's a classical battleship game. It's been developed in Python as well. And at this time, it's a multiplayer game. You play with your friend, you set up your ships. We take advantage of encryption that we can do inside the Cartesian machine so that the board is never reviewed up to the end of the game. And then once it's reviewed, you can just check that the whole game was played correctly. Because inside the Cartesian machine, you can validate the entire match and see if someone lied about a position of some ship, about hitting or not their own ship, and they can be always enforce the correct result, right? So it's also a really interesting game. It's being developed really fast because, once again, it's developed in Python and not on a really low level language like Solidity. And it also doesn't have to worry about a lot of restraints on the computation size that it would have if it was implemented directly on smart contracts.
Fantastic. Yeah, really excited about both of these games, and I think they also, for example, Ultra Chess not only sheds light on what's possible in terms of on-chain games, but it also kind of falls into this other category that we'll go over a bit later, with machine learning and AI. So it's kind of in between those two categories, and it's I haven't seen anything like it, honestly, and I don't think you can really build anything like that outside of Cartesi, and at least not easily, right?
And not decentralized, really, because it really allows you to have not only the computational power but all the tooling, right? So you want to do a genetic algorithm, you want to do whatever you want, you can just import the library, use it, and do the optimization or the calculation you want without having to re-implement it or to worry about, do I have enough gas around this? Do I have to break it down in multiple transactions? Do I have to combine them? So yeah, it really enables next level applications.
Love it, super cool. I have two more games here that are worth mentioning, I think. I mean, more than two, but that we included in the presentation for now. First is Dender. Carla, you want to go over that one a bit?
Sure. So Dinder is this game that's been developed by this Taiwanese game studio. It's really cool. For gamers, it's a mashup of Pokemon and Candy Crush. So basically, you have your own team on top of portion of the game, and you have these really cool avatars that they created. There are multiple themes. There are NFTs. You can switch and swap them and build your characters your own way. And once you choose your team member and the one you want to attack, you actually power the move by doing combos on this puzzle that's on the lower side of the screen. So it's really strategic. You every time you do a move, you gotta choose between either making the most damage you can or messing up the board so that the next turn your opponent doesn't strike you hard. And it's a very beautiful game. It's been developed in Unity, the client, so great graphics. And this is another example of a game that without Cartesi would have to be done in a Web 2.5 fashion. That is, you would have the NFTs and their management on chain, but this game logic, it's way too complex to be described on smart contracts on Ethereum or other chains. So you would actually have a centralized game with just hints of decentralization on the management of NFTs. Now with the Enders, since they use our tech, they're actually able to do it fully decentralized. So the whole game logic is implemented in Rust, which is their cup of tea. And it runs inside the Cartesi machine. So if anyone tries to tamper with a move, make it more powerful than it should be, mess up with a random number, nerf a character or anything like that, you can always just check the computation and enforce the correct result.
Super cool. Super cool. Really excited about Tinder. Life. Well, you want to go? I mean, it's based on Game of Life, but it goes a bit deeper than that. Maybe Carlo, you can kind of share that.
There's this problem called Conley's Game of Life. It's studied on most computer science courses, and it's basically a simulation in which you have the cells. They're either dead or alive. If they are dead and they have a certain number of alive cells in their vicinity, they become alive. If they are alive and they have a certain number of cells under the vicinity, they stay alive. If it's too high, then they die. And it's really cool because you can make all sorts of patterns. So you can make these patterns that oscillate, that generate artifacts that go through the grid, that does all this cool stuff. And in this specific game, which was developed for the San Francisco Hackathon, it became a multiplayer game. So each player sets a certain configuration of cells in the beginning. Then there's a simulation for a certain number of rounds. And then the player with most cells wins. And what happens is that you can just choose different strategies, right? You can try to replicate yourself as much as you can on a hidden part of the grid. You can do these patterns that generates bullets or ships to try to attack your opponent on another part of the grid. So it's a nerdy game, but a really cool one. This was also developed in Python. And it's I find it a pretty cool initiative.
Yeah, a lot of ideas and kind of directions that this game could go into. It was a hackathon project developed during East San Fran. It's not a completed game yet, but actually Blockchain, who's working on Ultra Chess, might decide to continue working on this at some point. Definitely an exciting one. I think also a lot of inspiration. These big grid games, I think, are also pretty well suited for blockchain games. A kind of multiplayer, turn-based, but over big maps, and then you can kind of see how things evolve over time. Pretty cool. some other ideas here, and I actually would like to point to I have this GitHub with a lot of ideas, and I kind of stole or grabbed some of those ideas here just to kind of reflect on them, and I'll drop the GitHub link in the chat. But there's a lot of and this is just some of the ideas, but potential inspirations for you hackers of kind of avenues to follow. From turn-based games such as tic-tac-toe, fully decentralized and persistent RTS, real-time strategy type games like Dark Forest could be interesting. AI versus AI games is what we just discussed. With Ultra Chess, stuff like cellular automation, simulation with game logic like Game of Life, Y-World, Forest Fire, etc. And then there's other inspirations like Core War 2D CPU, some kind of like old school games that, given Cartesi's programmability, could be sort of easy to port and would attract a lot of attention, I think, in terms of players as well that, have this desire to play these games with like on-chain. I feel like there's twists that you could also give them, and that could make them really interesting. I don't know, Carlo, do you have any other thoughts or ideas here that you wanted to some like little snippets or some thoughts?
I like tower defense a lot, and one thing that would be really cool would be making this tower defense in which you can set up custom tower behaviors. Like you can make your towers act like a squad. So first the sniper tower can hit it, then the slow tower will slow it a bit, then you bombard it with a minigun, things like this, right? Traditional tower defense games, you have these really simple actions like hit the one farther, the one closest, the one with highest HP, all this kind of stuff, which are really basic behaviors. But making a tower defense in which you can actually coordinate the towers, I think that would be really cool and really take it to the next level.
Like that. There's so many opportunities. Gabriel, as well, if you have any thoughts, feel free to open your mic. I'm not gonna throw you under the bus, but if you're free at any time, unmute yourself.
For sure.
And if you guys, while we chat, have any like ideas of games or of applications, use cases, feel free to drop them in the chat, and we can also discuss them and see if it's possible or yeah. Awesome. Let's go over to the next category, which is machine learning and AI. Pretty hype nowadays. I don't know if you guys played around already with ChatGPT and these other Midjourney, etc. Some pretty cool stuff. It's moving really quickly. It almost feels like crypto, right? Or maybe even faster. I don't know. Interesting stuff. So, what does the intersection of machine learning and AI look like? Machine learning, AI, and blockchain look like? Well, that's something that Cartesi can actually enable to a certain extent. And we have a few proof of concepts that we'd like to highlight here. Carlo, maybe you can kind of cover these three because they're sort of interrelated.
Yeah, so these three POCs were developed by AI researcher, and he was exploring multiple different techniques on Cartesi. So the first one is a classical one on the machine learning field. So we have this iris flowers dataset that he used to train models and to check if they can classify correctly the flower in question. And he implemented this program that goes through this dataset and does the classification inside Cartesi using Python as his language of choice. And the technique he used is called KNN, which is K nearest neighbors. So it's an interesting technique that's pretty simple, but powerful and can solve multiple problems. Another one that he implemented is this one with another classical data set for machine learning, which is a data set that has data on people that entered the Titanic and if they survived or not. And it has things like the age, the port they onboarded, their age, and then the model predicts if that person would have survived or not the Titanic accident. And in this one, it was a bit different. So what he did is he trained a model using scikit-learn, and then exported this model to pure Python code using a library called MC2Gen and M2CGen, sorry. And he runs this model inside the Cartesi machine. So this one is a neural network, okay? And then we have another one which is really cool, which is a classifier for biometric readings, in this case fingerprints. And the problem at hand is that you have these fingerprint systems in which people can clock in or clock out or authenticate or do different stuff. And there's a problem that people fake these fingerprints, right? So you can do a silicon finger, you can do a photocopy of it. There are multiple techniques that are used. You see in movies, 007 and others, using some dust to replicate the fingerprint. And this DApp is about this. So train a model that first classifies the fingerprint, who the person is. And then he made a program in C++ that processes this image and extracts the feature that describes it using a very well known library, which is OpenCV. It's a really complex library. And once he uses OpenCV to process this image and extract the features, he feeds it to a Python program that has a model that was trained to spot if a fingerprint was spoofed or not. So this problem has the ability of saying, hey, this is a real person, or no, this is someone trying to tamper with the system with a silicon fingerprint or something like. So all these three are really interesting AI machine learning problems. And they were implemented in C++ and Python using existing libraries and taking advantage of our Linux runtime environment.
Yeah, super cool. Yeah, awesome. We have two more here from actually a hackathon we participated in. Be My Coin and Gar on Chain.
So Be My Coin is this project developed on Ethereum in India, and they tackle a problem they have there with car insurance. So basically, in India, you have this car insurance in which when you try to use it, they can deny it to you based on a closed door analysis saying you're a bad driver. So yeah, they're not going to pay for your accident because you're a bad driver. And you have no say on that. It's done behind closed doors. And the only thing you can do is try to dispute this in court. So these guys, they developed this DApp in which modern cars, they have this ODB2 port in which you can just export all the data, right? And it has data of everything that's going on in your car, all the systems, how you accelerate, how you brake, all kind of stuff. And they export this data to the Cartesi machine. And inside the Cartesi machine, they have a model that processes data and comes up with a rank of how good or bad of a driver you are. And then on this Be My Coin, you have transparency on what happens in your insurance. If you're denied insurance, it's because you're a bad driver. And you're a bad driver because you have this model processing the way you accelerate, the way you brake, and coming up with a score of your driving style and saying you're driving in a reckless way. So everything is transparent. There's no closed door decisions. And in case someone makes a false claim about your score or anything like that, it's on Cartesi, so you can always dispute it and enforce the correct result. This Gar on Chain is another really cool application which also uses machine learning. And this one is actually using inputs from the real estate market to come up with prices for houses that are on the system. So it's a marketplace in which you can tokenize, for instance, rents, and then to know if that rent is appropriate or not and this kind of thing, they need to know the housing prices, and they use machine learning in order to infer what would be an appropriate price for the houses on the system. Once again, Cartesi machine, they can make use of any machine learning techniques they want. and they can process all this real estate data to correctly come up with a price for each house on the system.
Yeah, super cool. See kind of some like pattern as well. Like if you look at, we'll see a few more projects also in DeFi and stuff like that. But there's quite a few that focus on pricing and on calculating a score of some kind. And I think there's a lot of use cases in those areas as well. Pricing can be super broad. Like you could price. Okay, here they used price like houses. But you could price anything, like from even like just an NFT, like an art NFT based on a model again. Could score, the score calculator could be score used for a credit score. It could be a score that you use for a risk model, which we'll see a bit later. So there's a lot of there's kind of this pattern you'll see, and it's interesting, and there's a lot of possibilities around these two areas, I'd say. So let your imagination flow, but I think it opens up a lot of possibilities, I'd say, and doing all this in a verifiable way is truly unique, and I think is the future as well. At least for a lot of use cases. So a few other ideas here, again, taking from the GitHub link I shared earlier. Having this AI artist is one. Having explore the possibilities of a decentralized text to image generator. You could have I don't know if you guys are familiar with Boto. It's this like AI that generates art, and you have a DAO that votes on which piece of art they prefer, and the model learns from those choices, evolves. Like doing that in a decentralized way could be quite cool. Stuff around DeSci, like DeSci is huge, decentralized science, right? In this case here, you could build a verifiable compute solution, right? Being able to prove and verify that something was computed in a certain way is huge. And decentralized science is basically trying to solve that problem. And then Cartesi is a perfect fit for a lot of those problems that they're trying to solve. Finally, Carl, I think this is maybe an idea you mentioned, right?
Yeah, so on a hackathon, we had this really interesting idea. This girl, she would use something called fast shot learning, which is a way for you to train a model with a tiny data set. And the idea was that all these blockchain systems, you are your keys, right? So you lose access to your keys, you cannot do anything. And there's no call center, customer support, anything you can just contact and say, hey, reset my password or anything like that. You lost your keys, you're done. So this year's idea was using this fast shot learn model, in which you snap a couple of pictures of your face, you train this model with it, and then you store it. Taking a look at the model, no one knows who you are and what image, what kind of face would trigger it. But then if you lost access to your keys, you can just go there, upload your picture, the model will check that it's you, and we will allow you to change the keys to access that account. So it's a really interesting way of recovering your access, given that you lost your keys. And this idea would be similar, but instead of using pictures, you could use voice-based verification. And you could do like a dynamic thing. You generate a random sentence, you ask the person to say it, and then if it matches whatever you generated, and you recognizes the person, you grant her access to transfer the assets from one key to another one, because they lost access and they want to recover their account. So these kind of creative solutions for this problem we have on blockchain, I think it's a really interesting thing. And once again, you can take advantage of machine learning to come up with these creative ways of recovering accounts and other common problems.
Love that. Yeah, there's still a lot of problems around usability, and private keys are not always easy to manage. So these kind of abstractions are super useful, and you could pick up have a lot of demand, I think, from end users as well. Super cool use case.
Max, I don't want to break the flow, but we are getting some questions, and these questions are good to be answered because it helps people understand a little bit more and to explore their own ideas around Cartesi as well. So maybe I can answer those, but Carlo can answer as well. So first one is from Crypto Gambler X. He was asking what hardware aspects are Cartesi's RISC-V architecture? What about GPU, RAM, etc.? Do you wanna go, Carlo?
Sorry, I'm actually answering one on the chat here.
So, okay, I can go. So basically, Cartesi is an emulator, is a full, let me open my camera. It's an enclosed environment, it's a sandbox, and it has one CPU, and you can configure the other stuff such as RAM, the hardware drive space or SSD space, the long how is that? Whatever. You guys understand. But you don't have access to GPUs. You don't have access to second CPU drives. You only have access to a single one. That is because we needed to make the whole machine deterministic, and the very nature of GPU it's really messy. There is a lot of entropy happening on GPUs. So that ties a little bit as well with Sasha 1337, I guess in late question that was talking about AI PyTorch and some sort of magic. That will not happen anytime soon because of the GPU lack of feasibility for a deterministic environment. Okay, the second one.
Generally, these libraries can also be compiled to use CPU only. It's a hassle, but it's feasible.
Yeah, Sasha addressed that on the chat as well. Yeah. The second question from Crypto Gambler X is, what is the significance of running Doom on Cartesi rather than will it run? Interested in why it's important and what it means going forward. Did I address, Carlo?
Yeah, so the significance is that it's not something you can think about doing without Cartesi, basically. One is Doom has a pretty complex logic for you to reproduce on smart contracts. And it's a real-time game, so it demands a lot of computation done at the right time. With the EVM or other blockchain, yeah, you wouldn't be able to do it.
Yeah. Okay. Third one. zk Alpha mainnet just released. What are Cartesi thoughts on how well positioned it is to tackle the issues of decentralization, scalability, security, i.e. why Cartesi and not zk?
Okay. So there's a lot of fights between what's called optimistic rollups and zero-knowledge rollups. And let's just put some things in perspective. So all these zkEVMs projects and stuff, they are able to prove the computations in a feasible time. And they do it using multiple techniques to parallelize generating the proof, using huge machines, and generally there are a cluster of these machines. And they barely manage to do it on a feasible time. Zero-knowledge proofs, they're really hard to compute, okay? They grow exponentially, basically, with the computation size you're trying to prove. And in Ethereum, what you can do on a transaction within that gas limit, it's really tiny computations, guys. It's like what you do on a pocket calculator, okay? You cannot do anything that you do on your computer on these transactions, okay? Now, these zkEVMs, they are state-of-the-art on zero-knowledge proofs and all this stuff, and they can barely, using supercomputers, prove these tiny computations in feasible time. Now, what we do here in Cartesi, it's not these tiny computations. We do things that are much larger just by booting Linux. If you ask one of these zero-knowledge projects, hey, generate a zero knowledge proof that I booted Linux. They won't do it because they will need too much computational power for too long to generate a proof. There's a project that uses zero knowledge proofs and uses RISC as its base, called RISC Zero. It's a really interesting project. It has a lot of uses, but they don't boot Linux, and they don't boot Linux because they cannot prove that they booted Linux. So they cannot get to initial part of doing the computations we do, which is here's the OS. Now you do the real computation. Crypts, for instance, the tower defense game we did. A single match would take like an hour if you're a good player. And then with the Cartesi machine at the time that is much slower than the one we have today, it would take like 15 minutes to validate 1 hour match, okay? So it's a long time. But then we made the calculations. Okay, so we have Ethereum just for ourselves. No one else is using Ethereum. All the blocks, they're ours. Every single block mined each 30 seconds belongs to us, and we can use its full computational power. And on this calculation, it would take like 5 centuries or so to process a single Crypts game, which on the Cartesi machine would take 15 minutes. So imagine something that you can barely process in real time using a cluster of computers, which is what the zkEVMs do. And think about having this 15-minute Cartesi compute being performed inside of a zk prover. You're not going to make it. Okay, you can use all the clusters of supercomputers we have in the world, and it would still take a really, really, really long time. Okay, so it's a matter of the size of the computation. It's like thinking, I don't know, pick up a sports car. Sports car are really fast, yes, but they have the scope. If you want to carry exports that a cargo ship will take from China to here, well, it's not going to work. Basically, because you can carry just a small box, while these cargo ships, they can take basically a building on them, right? So it's a discussion with much different scales. It doesn't really make sense to say, why don't you do on zero knowledge rollups what you do on Cartesi? I hope I addressed it.
Yeah, so he has a follow-up. So basically, zero knowledge have an inevitable fate. It is not going to work. Why haven't anyone pick up on this? Sim Cortez proposing something no one even thinking of. Sorta. Not really that they have an inevitable fate. It's more like there's a limit to what is possible. There's a lot of applications for it. It's really good for certain things. It's just not generic enough. So
There's
whenever
another-
we are scaling up and trying to do things like we used to do in Web 2, it's gonna fail. It's still gonna be a useful tool to support other applications, even those applications Carlos was just mentioning, but it's not gonna be the actual base for it. It's not gonna be the fundamental piece to it.
You can look up for a different tech that it's more advanced than zero knowledge, which is called homomorphic encryption. Homomorphic encryption is the dream. You can do any kind of computation you want with complete privacy. And Google has made a compiler that you can take up any C++ program, you run through it, and it's computed in a homomorphic encrypted way. It's awesome. But once again, it's not feasible because it's even slower than computing zero knowledge proofs. So you pick up a really good machine, you try to sort a couple hundred numbers, which is a task that any pocket calculator can do fast nowadays. And it takes a long time. Okay. So once again, if we had the computational power to do homomorphic encryption, we wouldn't even be talking about zero knowledge proofs because it's a superior tech. But once again, it's not feasible. So the kind of problem we will tackle with homomorphic encryption, we have to come up with creative solutions and solve them with zero knowledge proofs instead. So all these things are their tools. You got to understand what they address, what's their benefit, what are their shortcomings, and use it in the right way, right? just like Cartesi. Cartesi is a really powerful tool. We know that it has a lot of applications, but you won't have me saying throw Cartesi at everything you got. No, it depends on the problem. For a certain problem, it might be better for you to just run it directly on chain. So every problem you have to analyze what's the requirement, what are the tools you're going to use to tackle them.
Yep. Let's see if there's any follow-up. But there is another question. On another use case, still by Cryptogambler X, financial audit using machine learning AI, real-time forensic accounting. If accounting is online, why can bots scour the financials and predict issues based on benchmark failures? Thoughts? And then I asked to clarify. Basically, he's suggesting to use these algorithms inside the Cartesi machine. So my take on this is, if you're already trying to find something like a flaw, like this is trying to find a problem somewhere out there in the blockchain, you don't necessarily need computational proof that you did it right, because whatever you gather as a proof is enough. So you can say like, oh, there is something wrong on your books, Carlo. And he's not gonna ask you necessarily like, okay, prove me that you did the right computation. He's just gonna say, tell me which entries on my book looks fishy. And he's gonna try to explain those if he didn't do anything wrong. So maybe there is not necessarily an application for these kind of algorithms inside of a verifiable computation environment such as Cartesi. I don't know. Maybe there's something I'm missing. Have any takes on this, Carlo, Max?
Not really. I mean, I guess if you were to do like bookkeeping for DAO or something, in that case, maybe it would make sense if you wanted to have everything on chain.
But that's the bookkeeping itself, right? Like that's the financial book.
It's not
it was
looking
talking
for...
about like the
Exactly. Yeah, I don't know. Maybe there's a use case somewhere, but I'm not sure if I see it yet.
Good.
Yeah, I think it's because a specific problem. So, yeah.
Yeah. There was just one more for the Twitter a while back. So Matt reached out to us on Twitter saying, "Hey team, I applaud your tireless improvement on the fundamental technical aspects of the project. Question: what measures, marketing, partnerships, etc., are being taken to increase awareness of Cartesi and its unique capabilities in a sector that is becoming increasingly competitive?" And to that, we have a news that next week we are gonna be releasing some information about some ecosystem updates that we are gonna be doing throughout the rest of the year, and these are gonna shed some light on exciting new initiatives that are currently underway.
Awesome.
I think that's it for now, Max. Yeah.
Yeah, cool. Let's go back to the presentation a bit. We have some other exciting verticals to talk about. Sweet. What's the next one? Generative art. This is a big one, and I think we batched it with, like, art is like a large concept, right? But anything that's generative, dynamic in a way could be interesting. And let's check out what this first example is. Carlo, the floor is yours.
Yeah, so this is the hackathon winner from ETH Bogota. It's called Fermendi, which is stands for the initial of their teammates. So what it did is there's these Mandelbrot fractals that are really computation intensive. It's an interactive algorithm. You can run as many rounds as you want, and you can go deeper and deeper and deeper on generating this fractal. And they generate these really beautiful art forms. And yeah, on Cartesi they have the computational power they need. They actually want to implement this in Rust. They can do it because Rust is perfectly fine to program on Linux. And they generate these really cool fractals, really beautiful. And you can make an NFT collection with it. and there's no way that anyone can tamper with your art, because if they do, it's not hosted on a server somewhere that one person can go in there and swap a picture or anything like that. It was just generated inside Cartesi in a provable, trustless fashion. So if someone tries to tamper with your art, you just dispute it and show this is the correct art instead, not the one that you're claiming. And this is another area that mixes a lot with AI and machine learning. So you can use something like Stable Diffusion, maybe try to put it inside a Cartesi machine and generate art from within it. You can do that for generating items on games. You can do it for generating NFT collections. So there are a lot of cool, interesting things you can do. You can try to generate music. So there's all sorts of stuff that you can do with different machine learning techniques within the Cartesi machine and generate these reproducible pieces of art, right?
Yeah, it's a super interesting topic. And as you said, yeah, it combines a bit of the machine learning stuff. Arguably, also, you could say there's some overlap with gaming for certain use cases. Like you could argue that, a multiplayer like Game of Life, at the end of the day, this map that you have is almost like a multiplayer kind of piece of art in a way. I don't know if everyone would agree with me, but I think yeah, there's interesting things in terms of using ML, um, also using kind of this multiplayer having different inputs from different people and creating something bigger can be quite interesting.
Do some crazy thing like picking up a couple of bots, each one with a different brush, and put it on a canvas, and then you have like really crazy, unpredictable art done by a couple of bots, done by multiple people. Might come something interesting out of it. Yeah.
Definitely. Um, so I think we covered most of these. There's also like a self-evolving, soul-bound NFT kind of thing. You could have, some of the inputs you use could be stuff that you find on chain based on, your activity. Maybe someone is, buying a bunch of NFTs or is active on different DeFi DApps or is signing certain things. You could use that as inputs to also generate something personal. And I think this is what this idea is kind of covering to a certain extent. You have an NFT that is sort of tied to you and tied to your history and evolves based on your behavior. It's also an interesting concept. Get to the next idea we have, IoT, which again I think will have a bit of overlap because, for example, Gar on Chain, which we talked about before, was the car one? Is that Gar on Chain, Carlo?
The Bima coin.
Bima coin, yeah, Bima coin, for example, you could argue is also sort of IoT, right? At least, the driver's behavior needs to be brought into taken from the real world and is used as input. Yeah, there's a lot of things here as well, but maybe you can talk about the proof of concept, the parking DApp that was developed a couple weeks ago.
Yeah, so this one was developed by a team in Poland. So they basically did this really cool application in which instead of having those counters that you're used to have in Europe, in which you put coins and you pay for a certain time, they have this decentralized application in which you provide your location, and then it tells you, oh, you're on zone X. Zone X has this kind of rate. You pay for it. Anyone can just go in there, check that you're within the zone, that you have paid to be parked in there up to what time. And they also have an interesting DAO that controls the rates and all this kind of stuff. It can also be swapped into city hall employees or anything like that. But again, it's a really nice idea. It works in a decentralized fashion. They've implemented it pretty fast in Rust and using a SQLite database to store the information, the business rules, all this kind of stuff to do fast queries. So it's a really interesting use of making a Web2 application in a decentralized fashion with existing tooling. and fast, right? There's a project that's ongoing also that's about monitoring water quality. So it's really cool. You get all these IoT devices that measure up water quality, consumption, all this stuff. And then you upload the data to Cartesi to do processing, to check for violations and this kind of stuff. You can also have supply chain solutions. So we got a couple of projects that are trying to export Cartesi to guarantee the quality of some good, that make verifications like, okay, so you're telling me this shirt is 100% organic cotton that came from sustainable villages. But now I see that this village you claim to have purchased the cotton from simply sold 4 times the cotton they produced. So all these kind of checks and things that they're really hard to pull out, or you have to trust a central authority, traditionally an audit from one of these bureau of auditors firm or something like this. You can actually build a transparent system with Cartesi, doing cross verifications, checking the entire supply chain in a decentralized and trustless fashion. So it adds a lot of transparency to the supply chain, right? We also have multiple projects that are tackling the carbon credits problem. So carbon credits, another industry that lacks a lot of transparency. Generally, you have a couple of entities like Vera that will just say, hey, you get like X carbon credits, and trust me, I've done the scrutiny. I checked that everything's fine, but there's a lot of room for errors and corruption in this kind of setup. So we have these projects that are bringing all the data on chain. Then you have the model that will process that data inside the Cartesi machine. And then anyone can just check, yeah, you're actually allowed this amount of tokens. You didn't tamper with it. You didn't pay a bribe or anything to get those tokens. And there are no mistakes. Anyone can just check, verify that the calculations are okay. And if someone tries to claim a token they shouldn't, well, can just dispute it and enforce the correct result.
Yeah, super cool. IoT, very interesting indeed in terms of verifying, monitoring, and then you can always have these triggers on chain, like issuing a certificate, issuing a token, a carbon credit, etc. A lot of kind of end-to-end solutions here that you can build out with Cartesi. Also curious about more. I don't think we're necessarily going to come up with them now, but like some more kind of crazy ideas, like kind of experimental stuff. Like, what about like something like Pokemon Go or something? Or yes, it's not really IoT, but I don't know. I think there might be some other interesting things that you could do with by taking inputs from the real world, from using IoT devices in a trustless way, and creating something. I don't know if anyone has some thoughts about that, but yeah, I guess, yeah, again, the possibilities are almost infinite, right? Let's check out the next one.
Denver?
That?
Yeah, I think we lost you for a second, man.
Oh, sorry.
When you were describing Pokemon Go and experimental stuff.
Oh yeah, I was just saying, like, I wonder if there's some other experimental ideas, because IoT tends to be often linked to supply chain, monitoring, quality control, etc. And those are clearly things that need to be solved. And doing that in a trustless way with blockchain stuff like that makes a lot of sense. I'm thinking, like, are there like some fun things as well with IoT, kind of like, I guess, Pokemon Go. I mean, we haven't really seen anything like Pokemon Go since, right? It was a big deal. But I wonder if there's kind of something using like physical location or using physical sensors and tying that back to Web3 blockchain that could be interesting to explore during a hackathon as well.
Yeah, definitely. All these geolocation applications, I think they're very interesting. And once again, in the blockchain, it's really hard to do something with them that's truly decentralized, because all these geolocation libraries and things, they're pretty complex on Cartesi. You can just import whatever you want and use it to process the matching, the distances, all this kind of stuff, right?
Yeah, I love it. Sasha, at the end, if you want, you can come on stage, talk a bit about your thoughts on IoT and Cartesi. Maybe you have some interesting overlap ideas there to share.
Yep, we can invite him to the stage. Yeah.
Yeah, just if you want to request, feel like it, of course, you can request.
Meanwhile, there was one more question for from Crypto Gambler.
Can you guys hear me?
I can hear you. I had a bit of a problem with Discord, it seems.
Okay. Let's wait a bit for Max and Bahas.
You can't hear me? Carlo, can you hear me? Oh, we can hear you well, Max. Okay. Carlo can't hear me.
Yeah, I cannot hear Max currently.
Me neither, but I can hear you now. Something's going on with Discord itself. I thought it was with me, but a couple of times now.
Weird. You still can't hear me, Carlo?
So I don't know if you guys got everything that I said before.
Can you guys see my screen?
Yeah, I can see the
Cool.
screen.
Let's move to trustless automation now. So we had this really interesting project in India called Automatic. And it's basically a decentralized if this then that, right? And the idea is that, okay, so you have this random logic that you want to have executed like a Python script or shell script or something. And well, in order to do it in a decentralized fashion and have guarantees that it's being correctly executed, Cartesi is needed. So that's what they do. They have a random logic that you can program executed inside the Cartesi machine with custom hooks. So it can be time, it can be an event, it can be whatever you want. So it's a really interesting project. And you can think about other automations as well inside Cartesi. Home automation, all this kind of stuff. Yeah, you can think about doing something that's decentralized and trust us using our tech. Another interesting project is this about competitive programming, also from India, called Decode. So you have all these platforms for computer marathons and competitive programming. And a problem that you have is, okay, so how can I make sure that it's being correctly evaluated, no one's tampering with the times, with the amount of resources I'm consuming, all this kind of stuff, right? Because generally it's behind a closed server and you don't really have access to that stuff. So what these guys did is, okay, let's pick up and make a platform of this inside the Cartesi machine. That way, if I say that your code is more complex than another one, that it takes longer to execute this data set and things like this, you don't have to trust it, you can just reproduce it. And in case someone makes a false claim of my code is faster than yours, or it covers more use cases than yours, or it's more effective than yours, well, you can just debunk it and dispute it and enforce the correct result. So it's a really interesting use case of our tech as well. DeFi, we have a lot of interesting ideas. So there's a project that was started at ETH San Francisco, which is Nucleus. And it's this protocol for improving borrowing and lending platforms. So it was inspired by the Mango hack. For the ones that don't know it, basically you have this lending protocol called Mango, and we have this problem in which a guy checked that there was an asset that could be taken as collateral that was really terrible on liquidity. He got like $5 million, purchased this asset. So by doing this, its price skyrocketed. And then he went there and he just said, "Hey, Mango, give me 150 million on stablecoin or something like that." Mango is a really simple protocol, so it just check an oracle to see what the price of that asset was. It was super inflated due to this purchase, and yeah, it says, yeah, it checks out. I can give you 150 million, and it gave the money because it didn't have the intelligence to check that it couldn't liquidate that collateral and actually get the money back. So Nucleus is inspired on this. What they do is they have this Cartesi machine running NumPy and other data analysis tools, and they do a couple of processing on top of the stream of data, including the prices, the volume, and other relevant data of assets. And then they can come up with a better risk analysis, saying something like, yeah, this asset is not good. It doesn't have the liquidity or the volatility to hold for a $1 million collateral. So if you try to liquidate it, it won't hold. You shouldn't use it. And get another one that's good quality, like Ethereum or something like that, and say, yeah, it's got great liquidity. It's not volatile. You can actually liquidate a $1 million being borrowed and have no issues with it. So it's a really interesting platform that can benefit the whole DeFi industry. Along with Nucleus, there are a lot of DeFi really cool ideas that you can do. So there's this computationally intensive analysis tools for borrowing, Black-Scholes, and there are multiple implementations already. So if you want to do it on Cartesi, well, be our guest. You can just pick up your preferred implementation and run inside it, and do this really cool analysis for lending. You got these order books as well. So the reason why all these decentralized exchanges, they're not based on order books is because you cannot really have order books on chain due to the amount of processing they take. With Cartesi, well, you can pick up an order book engine and you can just do your DApps order book based instead of using liquidity pools and alternatives. There's always these things that you can do, like we showed GAR and other projects that can use complex models to evaluate the price of real estate and other assets. It could be digital assets like NFTs. It could be other real world assets like cars, like crops, any kind of commodity. You can just fit complex models done by economists inside the Cartesi machine. The most famous ones, they already have multiple implementations in certain languages, C++, in Python, in anything you want. And yeah, you can just put them inside the Cartesi machine and start a really cool DeFi application from there. And beyond all these examples, we can have a lot of cool stuff. So identity things, reputation systems. You can take advantage of all the tooling that you can have on Linux to make your life easier. Come up with interesting ways of verifying your identity using OpenCV, using machine learning, using all these great toolings that we have available to make something that's more stable. You can do really cool analysis on a lot of data because you have databases, you have all these data analysis tools that are traditionally used, like SciPy, NumPy, all these kind of things. You can have evolving models on top of data, because once again, on the Cartesi machine, you have plenty of computational power. So you can have a model that evolves as you add more data to it. You can periodically retrain it using newer data to make it more efficient. So yeah, the sky is the limit. As we talked a bit earlier on discussion, you can make really cool governance DAOs. So a decentralized Kickstarter is something I would really enjoy seeing. So today we have these models of Indiegogo, Kickstarter, and others. And basically, once they got your money, you don't have a say on it, and you have to trust them. And most projects, I can tell it from personal experience. You fund them, and they don't deliver anything, and they're not accountable on what they did with the funds. So yeah, having a decentralized Kickstarter in which you can have a DAO with the people that funded it, in which the project owner has to keep delivering and keep showing that they're doing a great use of the funds they got, and you can actually enforce cutting the funding and get the money back in case they're not delivering. It's something really cool that I'd like to see. You can have all sorts of really complex decentralized voting mechanism. Once again, you got a full Linux machine in there, so you're not constrained to just locking some funds and doing whatever you want to with them. You can have reputation systems using complex business logic on that. You can have all sorts of weights on the votes using complex logic based on how much you cooperate on the DAO, specific knowledge you prove to have on a particular subject, like you're expert on a subject that's ongoing, so you can raise your voting power. You can really do much more expressive DAO voting using Cartesi. You can do things like gitting only on a decentralized fashion. So yeah, once again, your imagination is the limit. And you can build all sorts of cool utilities for our DevOps to use as well. So IPFS is a really good storage solution for storing things in a decentralized fashion, but it lacks the protocols to ensure data availability. So if you want to do some data sharding technique using Cartesi and IPFS combined, it's something really cool that we're interested. Do white label applications that are interesting for the economy in general. So a generic marketplace using databases and all the stuff that anyone can apply to a particular industry of their interest. If you want to do a template for Oracle's processing IoT data, all these kind of things, it's something that the community can benefit from it. And it's also really interesting. If you want to do some really cool feature that can be used on other applications, for instance, an alarm application, that can basically enforce that you have some input code at certain times, or other features that can benefit decentralized applications in general. These are all things that we really want to see people developing on the hackathon, or even further on a grant. Well, we kind of have the AMA all over the event, but now it's the time officially to take questions from the audience.
Who wants to come on stage? Please
just request to speak, and we can elevate you.
Elevate.
Okay, Crypto Gambler. I tried inviting you again. Check if you're able to. You're not working? Okay. Yeah, you can write down your message and we'll discuss it. So the tech itself can be deployed in the way that the developer wants, right? So we don't enforce any decentralization level. The app developer can choose how decentralized they want their application to be. So on one end of the spectrum, you can just say, hey, my application is going to have a single validator, and it's going to be me. And the only advantage from a centralized solution is that people can actually check I'm doing something nasty. They cannot dispute me because I enforce myself as the only validator, but they can still check if I'm doing something wrong. And that's one end of the spectrum. On the other end of the spectrum, you can have fully permissionless. So anyone can just come in, jump on my application and dispute a computation because they're interested on that bounty for debunking a wrong claim. And there are also setups in the middle. So for Cartesi Rollups, we're streamlining a framework that uses a committee. So if you want to use this committee that we're streamlining, you have a Heroku-like experience. You just push your code to a REPL, and we'll have automation that deploys Cartesi nodes with your code on this committee. And in this case, the trust assumption is that at least one person on the committee you trust will do the right thing, right? Because our tech has this security model that a single correct validator can enforce the correct result. And so to answer your question, it's as secure as you want. The DApp developer is the one that will determine which setup he wants. And it might resonate with the community for his DApp or not, but we don't enforce any particular setup on how decentralized an application should be.
I think there's something relevant here. That is because Cartesi is an app-specific rollup. So it means that you're not gonna plug into an existing network out there like the other layer 2 solutions, be it in optimistic or zero knowledge, where you would be sharing the resources with them. So you would need to take part in whatever setup they already had made it for you, right? In this scenario, no, you are deploying your own rollup for your own application. So that gives you freedom to choose all these properties that Carlo was talking about.
Any other question, guys? Don't be shy. And you can try to request to speak, and let's see if Discord allows it. And as we said, so if you have an idea later on and you want to discuss it, we're very approachable. So you can just throw us a message or something. We got Shaheen on Discord all the time that it's always taking a look at all the messages, and when there's something that comes up and might need some extra attention, he always brings to the rest of the team. We schedule calls with the people to really dive on their problems. So I think we do a good job on allowing everyone to speak and to be heard. So don't be shy to contact us on any idea you might have.
Yeah, 100%. I think we can close the call then. If no one else has a question or wants to jump in.
Yeah, Crypto Gambler is typing. So let's see his
Oh, he's typing. Let's let him type.
Yeah.
Zach as well. Guys, I'll start typing a bit. Send us something.
And that also something I like to stress is we had a mini revolution on our framework recently, and now we have a very powerful build system that makes it very, very, very practical to port libraries. So before you generally you would have to cross-compile things, and it's kind of a hassle. And now you can just apt install stuff. So if there's a pre-built binary for Ubuntu for the package you want or something like that, you can just make use of it. You don't no longer need to cross-compile everything you want to use yourself. Sure, Zach.
By the way, I just invited you into the stage, Zach, if you want to.
Who here, by the way, in the audience is hacking? Just curious. You could drop it in the chat. I recognize a lot of faces from the community. Curious who here is actually gonna, build something, or if you're, more just listening in, participating as a community member.
So you're devising a company that does Web2 identity verification. Okay. Interested in doing a decentralized ID system using Web2 tech.
I see. I think the most important point is the first bullet. His Web2 computer vision verification code runs on a Linux VM, and then it processes the sensitive data for the people. Can you do it? Technically speaking, there is no impediment to do that. It just works. If you can run it in your machine right now, it can run inside a Cartesi machine as well. Should you do it? I guess that's more of the moral / philosophical question here, because of the way the rollup works, especially optimistic rollups, you should know that you're putting your information on chain, and that's gonna be there for forever. You have to assume that that's gonna be there forever, and you have to think about the consequences of data laws regarding this type of sensitive information, and then you have to think about whether or not the user would be fine with that. So it's a bit sensitive. It's
yeah, gotta have more information about it. So a guy from our team for Bogota, for instance, he developed a whistleblower protocol, which in Ethereum is called Semaphore. He did an equivalent implementation using Cartesi. And in that case, what he did is he put risk zero, that zero knowledge risk machine we spoke earlier, inside Cartesi. And he used risk zero to generate, to validate that someone that sent a message is a valid whistleblower. So the message would come with a proof that he's a valid whistleblower. Inside Cartesi machine, he would take this proof and check, this is a valid proof. So you can take this message from this whistleblower without revealing who the person was. So again, should understand better the problem, the requirements. It's something you can do. And as Barros said, everything that goes into the Cartesi machine, it's a public input. It goes through the blockchain. But there are smart ways for you to combine zero knowledge libraries and ways of making sure that whatever you're doing is still decentralized, trustless, verifiable, but that you're not revealing too much information about the user.
So in general, it's possible. It's just a question of if this information should be public or not.
You gotta understand the problem better. once we understand the problem, the data they got, what they're trying to achieve, there are ways we can come up with a processing that gives the necessary proofs without revealing too much data.
That makes sense.
Crypto Gamer X, do you care about elaborating a bit on your question? How's Cartesi handling possible metadata leakage whenever rollups run?
So yeah, I think he was typing this while you were replying. I think it's still related to the question of Zach. So basically, you should assume there is no privacy. It's just like the EVM, it's just like Bitcoin for that matter, and the information is public. The whole information is public. Can you try to be smart about it and do some tricks and try to obfuscate information? Sure, but you should assume that the information might be leaked. Then there is what Carlo is talking about, that is adding to whatever complex logic you already have for your DApp. You can have some smaller zero knowledge proofs to certain things that you shouldn't be sharing on chain. Those are possible. So then GDPR, in this sense, would be applicable if you're verifying information off chain and just putting the proof on chain. So you're not liable by GDPR in that sense because there's no user information there. In principle, you might be doing something else wrong. I won't say about the whole app, but in that corner of your application, it might be safe.
So just to give you an example of a sensitive application, you might have something that needs medical records. Let's say you want to do statistics on on some kind of collateral effect on patients taking a drug. You might feed all their information, like the vitals, the readings on blood exams, all the stuff, inside the Cartesi machine, do all the computations you want, and then you can generate a zero knowledge proof on the outside to check that that is actually a person from the test group, that it wasn't tampered with, that no one fabricated that data to mess up with your results. So you can still verify everything on Cartesi, check that the calculations were done right, that your study is valid, that you're not messing up with made up information from someone that's not from the study, but you don't actually disclose anything from their identity because you use the zero knowledge proof to say that that was generated from a person from the study without revealing who the person was. So this kind of smart designs is something you should come up with, and they're basically dependent on the application you want to do.
So he was talking about as well about the biometric fingerprint app. Yes, there is the possibility of somebody grabbing that information and doing something with that, but that sort of is also related to the system that is verifying information as well. So in the DApp situation specifically, there was spoofing detection, meaning that one input could be only be used once. It would be able to learn whether or not a person is trying to spoof. So nobody could just take a picture from somebody else's fingerprint and run with it. However, can that be stolen and applicable to other systems? Potentially. It was a proof of concept app. I don't think it will be it could be like launched on mainnet or something as is without any modifications. So here's the thing, and that's a good segue, I guess, for the technical workshops we're gonna have on April 11th. The way Rollups works is it's extending the capacity of the base layer's ability to process information. However, all the information still needs to exist in the Ethereum context, for instance. which means is there is no layer of security that you can add that will hide the information from people, because the whole principle of rollup is making the information available so everybody can compute the transaction and verify that you are not messing with that. So the only thing that you could go, the only way you could go about this is trying to use some level of encryption for certain things, maybe just verifying signatures depending on the information you want, or maybe using zero knowledge, or even the homomorphic cryptography that Carla was saying, but that comes with a lot of limitations. So if it is not something small in your project, like KYC verification, or some kind of like ID, like Sasha was saying, they just want to say like, hey, this is a human being, and just the Boolean information, like are these people allowed into the system or not? Are these people allowed to do certain action or not? That you need on your DApp. If you need extra information, then it becomes a problem when it comes to privacy, yes. I don't know how Automata works, but I'm guessing just by the very fact that it is an external data provider, that you would need to face the issue of going through a Oracle. An Oracle are not safe by their definition.
Yeah, all these security requirements we're discussing, we can say generic things about them, but you must always check the problem. So depending on your application, you might have problems with replay attacks, which is you pick up something valid, someone throw at you, and you just use it again. And then you can just, as the text name says, replay it. So on this specific problem I said about recovering your access with your face, that's why you should change your keys on that example, because otherwise people already know, oh, so this face can unlock this account, and they can just replay it, right? So all these applications, when there's security needed, you must always analyze all the use cases, all the corner cases, make sure that you're not vulnerable to all kind of classic attacks, like replay attacks, for instance, and that the data that's sensitive should be kept safe and shouldn't be released, all this kind of stuff. And this is a whole world. So in traditional computing, even Web 2, you have entire areas of research about every single one of these kind of attacks. Cool. Anyone else has a question, would like to say something, would like to make a comment, doubts? If so, this is the time.
Just one person writing. Okay. Mr. Damon.
Okay. I don't see him in the call, yeah.
He was just here, but I think he disconnected.
Okay. I guess that's it, Max, right?
Yeah, we're not going anywhere, so any other questions, drop them in the Discord. And let us know if you want to discuss anything, jam on some ideas for the hackathon or whatever. We'll all be around. And yeah.
Thank you all for the questions, especially Crypto Gambler and Sasha.
Yes. Thanks everyone for joining. Thanks Carlo, Gabriel, Zach for being
Bye,
here,
guys.
and talk to you
See you
soon.
guys. Bye bye.
Bye.